This is number 13 from the review. Here we are wanting to set this equation equal to 0 so that we can simplify to identify where our function crosses the x-axis or is undefined. Then from there we're going to use our graphing calculator to tell us where it's less than 0, since that's what we're looking for with this function. So the first thing we're going to do is bring our 2 over, so we're going to subtract 2 from both sides. So we have 2x minus 6 over 1 minus x, all minus 2 is less than 0. And I left that gap there because we're going to need to find a common denominator so that we can simplify. Our common denominator is going to be 1 minus x, since that's the denominator for our other fraction. So this is going to be 1 minus x over 1 minus x. Again, we can only multiply by 1. It's a fancy form of 1. That 2 only applies, that negative 2 only applies to the numerator of our function. So our next step looks like this. Our denominator is 1 minus x. So you only need to write that once now. And then we can combine and smush together our fraction and combine the top. So 2x minus 6 stays the same. And then I'm going to distribute this negative 2 through our parentheses. So I get negative 2 plus 2x. And then all we want to do in the numerator is combine our like terms. I have 2x and 2x, so that gives me 4x. Negative 6 and negative 2 gives me negative 8. And there you're done with the algebra. So now we know from our numerator gives us our 0. So our 0, or x-intercept, we set 4x minus 8 equal to 0. Add 8, divide by 4, we get x equals 2. So that's our x-intercept. Our x-intercept is 2, 0. And if we set our denominator equal to 0, we get x equals 1. And that's at our vertical asymptote. So that gives us our 2 places to look to see what the graph is doing there. Our 0 and our vertical asymptote. The other thing that we can expect from this equation is that, or this function, is that we're going to have a horizontal asymptote at 4, since our function, it has the same degree on top and on bottom. We have x to the first and x to the first. Our horizontal asymptote is the ratio of our leading coefficients. So we have 4 and negative 1, since we have that negative x there. So our horizontal asymptote we can expect to see at y equals negative 4. That doesn't really, we don't really care about that as far as where our solution set is, but that helps us kind of know what our function is going to look like. So when you graph this on your calculator, you should get something that looks like this. Again, we have an asymptote at y equals negative 4. We have an asymptote at x equals 1. And we have our x-intercept at x equals 2. For this problem, we wanted to identify where the graph is less than 0. So our graph here is, or our function is less than 0 from negative infinity to 1 for this whole, because this whole part over here, everything over here is less than 0. So negative infinity to 1. We don't include 1 since we're just doing less than here. And we're less than 0 from 2 to infinity. And in set notation, It would be x such that x is less than 1, x is greater than 2.
Made with Doodlecast Pro.